Hello everyone, this is the next video uh, on real analysis. So we will be discussing higher order partial derivatives. So we already discussed what is fx, that is partial derivative with respect to x. It is limit as h tending to 0 f of a plus h comma b minus f of a comma b by h, and this partial derivative with respect to a point a comma b we were discussing. But what is this f double x? It is the derivative of fx partially with respect to x. How it is defined? See here, while considering, first I just want you to think in this way. X is there. First consider this. Then you need to introduce h. If you have f y x, you need to introduce, first you consider y, you need to introduce the small change, step size is k. So look here, x is there. So since x is in the first, I will take limit as it tends to 0. Then what else left? X is there. You take that fx. It is the, you are finding the partial derivative of fx. In fact, that's why fx is here in the picture. Here also it is fx. Here it is fy. Now, what is f double y of AB? See, as I said, you consider the first one, that is y is there, so you need to introduce the small step size, that is k is tending to 0. Then you need to take fy, and the increment is with respect, if you are introducing k, the increment is with respect to y axis, that is the second coordinate. Here the increment, since you had introduced x, the increment is towards the first coordinate, x coordinate. Similarly, what is fxy of AB? See here, as I said, fxy of AB. First you consider this. That means you need to increment with respect to x, that is you need to consider h. And whatever the function is there, it is fy, left out. Yavadu ulkolutto adu, that is fy. Now it is fy. See, how you need to increment. Since h is there, it corresponds to the increment with respect to x. H always corresponds to the increment in terms of h. So a plus h comma b minus fy of a comma b by h. Similarly this. Idea is clear? ಸ್ವಲ್ಪ practice ಮಾಡಬೇಕು ಇದನ್ನ. Again, there is one problem. Find fxy at 0 0 and fyx at 0 comma 0. See here, in order to find, let me write what is that fxy at 0 comma 0. It is, as I said, first you need to consider x. So increment I will give in terms of h. Then y is left, so you take that fy of, here I will say a comma b itself. So it is a plus h comma b minus fy of a comma b by h. But a comma b is 0. So fxy at 0 comma 0 is limit as h tending to 0 f y of h comma 0 minus fy of 0 comma 0 by h. However, we need to find fy at h comma 0 and fy at 0 comma 0. So first let us find what is fy of a comma b. It is limit of k tending to 0 f of a plus h comma b, sorry, a comma b plus k minus f of a comma b by k. ಅರ್ಥ ಆಗುತ್ತಲ್ವ ಇದು? ಸೊ ಲಿಮಿಟ್ ಆಸ್ ಕೆ ಟೆಂಡಿಂಗ್ ಟು 0 ಎಫ್ ಆಫ್, ಇಲ್ಲಿ ಎ ಅಂದರೆ 0 comma 0. ಈಸ್ ಆಸ್ಕಿಂಗ್ ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್. So 0 comma k minus 0 comma 0 by k. But f of 0 comma 0 is given as 0. So this is 0. F of 0 comma k ಏನಾಗುತ್ತೆ ಅಂತ ನೋಡ್ಬೇಕು ಈಗ. You put x is equals to 0 and y is equals to k. 0 into something, it is 0 by k, limit as k tending to 0. So it's 0 ಬರುತ್ತೆ ನೋಡಿ. After that, you need to find, this is over, fy of 0 comma 0. What is fy of h comma 0? ಇದನ್ನು ಪತ್ತೆ ಮಾಡ್ಕೋಬೇಕು. That is limit as k tending to 0. ಅಲ್ಲಿ ಪ್ಲಗ್ ಮಾಡ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ. ಸೊ ಏನು ಹೇಳುತ್ತದು, see in place of a you need to take h, in place of b you need to take 0. So it is h comma k minus f of h comma 0 by k. ಈಗ ನೋಡಿ, this is equals to limit as k tending to 0, f of h comma k is hk h square minus k square by h square plus k square minus f of h comma 0 ಆ 0ನೇ by k by 1 ಅಂತ ಬರ್ಕೊಳ್ಳಿ. ಲಿಮಿಟ್ ಆಸ್ k tending to 0 hk h square minus k square by h square plus k square into, I will write this as 1 by k. So you will get limit as k tending to 0 h square minus k square by h square plus k square. Idea is clear? Then limit as k tend to 0 is there. So what I will do is limit as k tending to 0. Here I will take h square out. So it is 1 minus k square by h square. Here I will take h square out in the denominator. So it is 1 plus k square by h square. So h square and h square will be cancelled. As k tends to 0, this is 1 minus 0 and 1 plus 0. So it is h. So this is 0 and this is h. So what will happen to your fy of 0 comma 0 as limit as h tending to 0? This is h, we find it, and this is 0 minus 0 by h. So it will be 1. Similarly, if you find fy x at 0 comma 0, you will get minus 1. But one observation is that they are different. Both are not equal. When they will be equal, when f is continuous, when the functions of several variable is continuous, then you will get the equality. Idea is clear? Thank you.